Alright, so this is our car here. Obviously you can tell right off the bat that the ultrasonic sensors are missing, and that is because we are not allowed to use the ultrasonic sensors for this experiment. We also are not allowed to use the line tracking program. However, we are allowed to use the infrared sensors, which we are actually using to detect when the car has the object, in this case a ping pong ball. So basically what we decided to do was have the car just keep moving forward until it registers that the ping pong ball enters the forks, which you can see that the light turns off, registering that the ping pong ball is in the gate. So that's the first implementation or function that we have. And the other function that we have is once the car registers that the ping pong ball is in the gate, or in the forks, this servo here that was used for the ultrasonic sensors will actually close the gate and hold the ball in between the forks while it completes the entire course. So the way we designed this fork here was obviously first of all start off with a fork, and that holds the ball in front of the car while it turns or moves forward. The other issue would be is if the car goes backwards, so that's why we also implemented a gate. So the last thing that we wanted also was to be able to register when the ping pong ball or object is in the gate, so that way the car knows it has the object and now can complete the course and leave the object where it needs to go. So that's where we implemented the infrared sensors, and we wanted to design it without needing fasteners, so that way it would be easy to manufacture and assemble. So basically I made it kind of like a puzzle piece where you can just basically slide it right in between the key slot there at the back of the fork. So you drop it in and slide it into place, and now it's in there. This is overall pretty cheap in manufacturing. It could easily be plastic injection molded, and there's little to none fasteners that are needed.
So now we'll go over the course and the code that the car follows. Once we turn on the car, it will enter a while loop and continue going forward until the infrared sensor is triggered by an object entering the forks. That uses an if-else statement to break out of the while loop when the infrared sensors are triggered. Then the code tells the servo to close the gate. It goes on its L-shaped path, and before each line of code for movement, we add a delay, because when we do not have a delay, we find the accuracy of the path is thrown off by the inertia of the car. It will do the L-shaped path, then stop, then open the gate, leaving the ping pong ball at the endpoint. Then the car will reverse to clear the ball, then close the gate, then do a 180 and continue going forward till it makes its last turn. Then it'll go forward for the last time and finally doing another 180 to return to its initial starting position it was in when it picked up the ball.
And so now we will demonstrate it. Alright, so I'll turn this car on and it will keep going forward until it detects the ball. And right as it does so, it'll close the gate and complete the L-shaped path, drop the ball, and return back to its original starting point where it got the ball, which is right here.